Welcome everybody. How are y'all doing today? Holy cow, let me get comfortable here. Sorry about Tuesday night, everybody. I had just got overwhelmed with a lot of stuff, so I had to push back to tonight. So thank you for putting up with me. And I'm doing this kind of like I kind of do this once a month or what have you, but we're doing a live Q&A. So if you've got any questions, ask them. I will do my best to answer them. But in the meantime, I'm going to be doing a little bit of designing. We're going to make some fun little kids' toys or something, tonight. And we'll get a little lesson in, making something. Yeah. So if you have questions, start typing them in. First of all, let me just say hello to everyone. And then Darwin, I'll get to your question since you've already got it up there first. Awesome. How are you? Let's see here. Welcome, Harvey, Mike, Kevin, Bruce DeCarmo. Welcome, bud. Let's see here. Let me see. Hello, everybody. All right, Darwin. Darwin says, Lainey, when you save the project you're working on, do you save save as or just save? Well, save as is when I'm first saving the project because I want to save it as this. I want to give it a file name. So the very first time I'm saving that project, it's save as. And then throughout the process of while I'm designing and stuff, I can either click the save icon in the software or just go to file save because I'm just saving that file. But the first time I've got to name the file. So save as is your first save of that project and then save after that. Good question. Good question. All right, let's see here. All right, so I'm going to share my screen with you guys. And there we go. What I'm going to do is I'm going to make just a fun little thin, kind of almost like a pocket tic-tac-toe game for kids, right? We're going to start off with a very simple, it's got a little lid, holds all the pieces and everything. Very simple little tic-tac-toe project, just kind of messing around. We're going to do some designing and stuff while I'm answering your questions. And we'll, go from there. All right. So right now I've got a project set up that's basically, it's a 12-inch, 1x, let's go 7.5. So we'll make it a 1x8 board. 1 by 7.25. So just a simple 1x8 project board there. This is what we'll use. I'm going to be touching off on the surface material and starting in the bottom left corner. So 12 by 7.25 by 3/8 inches thick. So it's going to be 3/8 inches thick. And then I'm going to be cutting some of the parts out of a 1/4-inch piece of thick material, probably most likely like 1/4-inch plywood or something or what have you. But that'll be my job setup. So let's go ahead and answer Jeff's question. Jeff says, hey, I have a question. What is the proper tool setup for a drill to drill 3/8 inch diameter hole through 3/4 inch thick plywood? I have 6 in a row to do. Well, I am a big fan of pocketing out a hole versus like a drilling toolpath. So in the software here, I'll just kind of show this, Jeff. If I was using a drilling toolpath, I would have to use a correct diameter bit, like a 3/8 inch diameter bit, right? Well, we're going to be doing a 3/8 inch hole with a 1/4 inch bit. So it'll be a pocket cut. Let's say that I have that 3/8 inch hole, 0.375. Let's just throw that right there on the screen. I'm going to pocket that out through my material at 3/4 inch thick. I'll use my 1/4 inch end mill for that. And that will guarantee a few things. One, that my hole will be perfectly sized for that 3/8. Because if I'm using, let's talk for a minute, like a 1/4 inch hole, right? Let's say if this was holed with a 1/4 inch. If I'm drilling a 1/4 inch hole with a 1/4 inch drill bit, if I'm come down too fast on it, I have an opportunity for that bit to flex a little and kind of slightly wallow out the top of the hole. So if I use an undersized bit, like if I use a 1/8 inch end mill to cut my 1/4 inch hole, then it won't wallow out. You know, I'll get a nice, perfect, clean 1/4 inch hole. In our case, we're cutting a 3/8 inch hole with a 1/4 inch bit, and then we're going to run it as a pocket toolpath offset. And we're going to, let's hit edit here. And 125. And, you know, then we would calculate that hole. Yes, we're cutting through our material. And, you know, we would drill out that hole that way. So that's how I would approach that, Jeff. So a 1/4 inch diameter bit, draw your 3/8 inch holes, and do a pocket cut. A pocket cut. That would be the best way to do it. Give you some nice clean holes. If you need the holes oversized or undersized slightly for whatever reason, then you can put in a pocket allowance. You can put in a pocket allowance. Negative number is going to be a bigger hole. A positive pocket allowance is going to be a smaller hole. All right. So if you need to slightly sneak in on that fit for your dowel and all, you can go negative 0.002, like 2/1000ths of an inch, and just slightly over big so that, you know, fits in just perfect type of thing. If you wanted to, first of all, do it with no allowance and see what your fit is. If you need to make it a little bigger, add a little bit of an allowance to it. All right, cool. Very cool. All right, so yeah, let's back up on let's back up on Darwin's question about saving and all. Troy throws out that there's also an increment and save option. And Troy, and that's an option that people don't use very much. But the increment and save, let's go to a full screen here. The file increment and save, what that does is it saves, let's say that this file name was called tic-tac-toe board, right? As I increment and save, it will put a number behind that. Tic-tac-toe board 1, 2, 3, 4, 5, and everything. And, you know, if I have to go back a revision, I can just open up number 4, right? You know, if I got to step back something and all. So we can increment our saving, and it'll put a number behind each file name for that project and stuff. And it's something that people don't use very much. But if you have to kind of create revisions that you might need to backtrack on, increment and save is a good option for that. So thanks, Troy, for throwing that out there. That's a good, you know, not many people use that much. Or, you know, really, you know, a lot of people might not know about it, but that's good that you brought it up. All right, let's get rid of that pocket, and let's move back over here to my 2D view. And let's get rid of this circle, and we'll move on to the next question. Let's get this centered up. Left, there we go. Now, what I'm starting off with here on my 1x8 12-inch long board, 3/8 inch thick, is I'm starting off with a 5-inch by 5-inch square. All right, 5-inch by 5-inch square. And we're going to have, we're going to put both the lid and the gameplay area on the same board. We'll cut them both out of the same board. And so what I want to do is I'll mirror this right here. I'm going to create a mirror copy and flip it about job center, and I'm going to flip it horizontally. So I have 2 of them there. Cool. All right, let's go on to the next question. How do you keep track of all the Vectric files? Do you group by tool, laser, 4th ASIC, etc., so on and so forth, or some other way? Harvey, that's a great question. How do I save my files and everything? When I'm training the customers, my customers and all, usually the first thing that I have them do is in their documents folder. And now this computer probably isn't set up properly, but we're going to see how well I follow my own instructions, right? In the documents folder, I usually have them create a folder called CNC jobs. That's the filing cabinet. Think of that as the filing cabinet. And inside that filing cabinet, every job has its own folder. Okay? Every job has its own folder. And inside that job folder are the toolpaths, a preview image of the preview cut and the design file itself. So every job is nicely organized. Think of a filing cabinet. We open up the drawer of the filing cabinet. Inside that drawer, there's all those job folders. And inside those folders are reports and receipts and all that stuff. Well, for us, it's our design file, maybe a proof image, and in all the toolpaths. So nice and organized. And, you know, that's how I have them organized. Now, as far as subcategorizing them, even further into fourth axis or this or that, you know, I could, in my CNC jobs folder, I could create another master folder called two-sided projects, fourth axis projects, you know, acrylic projects, whatever, right? You could break it down even further, but I don't have those subcategories and everything. I just have my master job files inside my CNC jobs folder. Okay. So, but that's a great question. So that's how I do it. You can set up whatever system works for you. And, you know, if a holiday type theme, like, you know, you want Christmas, Thanksgiving, Valentine's Day, you know, type projects, you can break those categories down and put those projects inside there and, you know, really kind of have those sub levels, you know, and stuff. And that would be good, right? There'd be nothing wrong with that. So, that's a good question. All right. So in here, I want to create the gameplay area. So what I'd like to do is I'm going to do an offset of this is my outer perimeter here. I want to offset inward, and I want to offset inward about 1/4 of an inch. So we'll go 0.25, and I don't want sharp corners on this necessarily. And that's going to create kind of my gameplay area. Well, part of my gameplay area. Now I'm going to offset another 1/4 of an inch. Okay. And this is my gameplay area here. This area here that's going to get, that's going to be some wood, a wall of my wood. And this is going to be milled down here so my lid can fit on it. All right. So as we move along, hey, Crisscross Grass got here on a Thursday early. Hey, buddy, what's happening? All right. So we've gotten that far. We've got our vectors mainly laid out. Now we're gonna start dividing this up into some tic-tac-toe gameplay area right here for this little kids game. And again, it's out of 3/8 inch thick material. And we got to get some vectors on our lid here. So I'm going to actually copy these vectors over to the other side. So I'll mirror those as well, flip horizontally, and get those mirrored in there also. All right, cool. So we're there that far. Let's answer the next question. When I do a VCarve to a flat depth and use a couple different larger area clearance tools like 1/4 and 1/8, usually the 1/8 will spend the vast majority of the time just poking up and down. Right, exactly. Joseph, what's happening is in your design, the 1/4 inch end mill is doing a majority of the work, right? It's clearing out all the large pockets and things. And wherever it can't fit, then those little nooks and crannies that 1/4 inch bit can't get into, the 1/8 inch is going to take over. And where the 1/8 inch bit can't get into, the V bit has to take over and do those flat areas. So for your design, you know, your 1/4 inch might have taken a majority of that stuff away, and the 1/8 inch only has just a few little areas that it could probably touch up, if especially around letters and things like that, words and stuff. And even the 1/8 inch diameter is too big to really get in there. So it just kind of pokes around and does what it does where it can. And then, of course, the V bit's going to come over and have to touch up, you know, where those two clearance tools didn't finish off. So what you've got to look at is, you know, if you're going to use multiple tools, if the 1/8 inch bit really isn't doing anything, then eliminate it and then let the V bit just kind of clean those areas up, right? Do the 1/4 inch do the majority, and then let the 1/8 inch bit clean up in there. But if there is some majority areas where that 1/8 inch bit can fit, and it is actually doing something instead of just kind of poking around where it can, you know, and kind of cleaning up little bits and pieces and stuff, then great, you know, use it. But yeah, that's what's happening. I don't know if that helped answer your question, Joseph, but that's kind of the gist of what's going on. To follow up with your follow-up question, not really doing anything, is there a way to fix that? Eliminate it or reduce down to a 1/16 inch end mill, right? Because that 1/8 inch end mill is just too big to really get where it needs to get to, you know, for those smaller areas and stuff. So the V-bit's taken over. So you could, you know, eliminate that and get a 1/16 inch end mill. Toolstoday.com sells them and other places and all. But you could get a 1/16 inch end mill, which would do a lot more work, right? And the V-bit would have to do less work. But, you know, if that 1/8 inch really isn't doing nothing, eliminate it and go with a smaller diameter bit, right? So that's kind of where we're at there. All right. Cool. All right. Let's, hey, Crystal, how are you doing? Appreciate you coming in and joining us. Let's answer Tim's question, and then we'll move on to the design. How do I create a vector around a perimeter of an imported bias relief model so I can do a final profile cut when I remove the model? Excellent question. So basically, how can I create a perimeter? Let's go ahead and create a new layer here so I can work on it. And we'll just turn layer 1 off for a minute. And let's go into our clip art and let's grab a bias relief model. Whether this is a model that we purchased online and we're importing, or it's a model from the Vectric clip art library, whatever the case may be. Let's go ahead and I'll just, for kicks and giggles, let that load up for a second. Model files. My computer, I'm waiting for that new computer, man. It's got to get here quick, hopefully, but not really. It's not. It's taking its own sweet ass time. Okay. All right. So so I got a model here. Now I need to create a profile around it because I'm going to cut it out, right? Very simple. In the modeling tab down here, the third icon, it looks like a little top, a little spinning top. You know, the spinning tops, it looks like a little spinning top on its side, and it's got this blue perimeter line around it. This is to create a vector boundary around a selected component. So my cantering Arabian is selected. When I click on that, that will create that outline profile. And so we can see that outline profile there. That's all you do, right? And then you can use that profile for modeling boundaries, for profile cuts, whatever it is that you need to do. All right, but that's it. Just click that, select your component that you want to put a boundary around, and click that button there, and you're set. Okay. Now, if you're in Aspire, that button is further down. I think it's like the second row of tools, but it's still the same looking icon, right? And let me go with a bigger screen just so you can see what that, a little bit better what that icon looks like. Just looks like a little spinning top on its side with a blue perimeter line on it. Right there. Okay. Awesome. 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 Okay. So let's get rid of that. Let's go back to our, delete that out of there. Let's go back to our layer 1 where my design is. And now on my design here, what I want to do from here is I want to divide this up into a tic-tac-toe kind of playing field, right? And let's basically let me get these toolpaths created so you can see what's happening here. All right. So the first thing is on this toolpath here, I'm going to take my boundary over here and I'm going to do another offset slightly outward by just 1/16 of an inch. Not much. A slight 1/16 of an inch. And the sole purpose of that boundary is so I can select it with this one here. And let's close this for a minute. The whole purpose of this boundary out here is to select it with this inside one so I can do a pocket cut. And my material is 3/4 of an inch thick. Now you guys are going to see some keyboard shortcuts, so pay attention. I'm going to use the letter T. T for thickness. The software knows how thick my material is. It knows it's 3/8. And I'd like to leave 1/8 of an inch of material. You know, I want it to mill down and just leave 1/8 of an inch of material. So T minus 0.125 equals 1/4 of an inch, right? So 3/8 minus 1/8 is 1/4, right? And I'm going to use a 1/4 inch end mill here. I'm going to offset cut it. I'm going to add a ramp. I'm just going to add a 1/2 inch ramp here, not too many decimal points. And this is going to be my outer pocket. This is going to be my base part. Outer pocket. And I'm going to go ahead and throw in the bit that I'm using, 0.25 end mill. And let's calculate that out. Cool. All right. So now we have that pocket there. And for kicks and giggles, I'm going to go ahead and take this vector and do a profile cut. That's what's going to get cut out. And that's going to cut all the way through my material, 3/8 of an inch, with that 1/4 inch end mill on the outside of the line. I'm not going to put tabs on this. I want this no tabs for preview purposes only, but I will put tabs on it before the final save and everything. But I'm not going to put tabs on it. I will do a ramp on this. I'm going to do a nice zigzag ramp. We'll go, again, just a 1/2 inch ramp is fine. And this is going to be my base profile cut, 0.25 end mill. And let's cut that part out just so we can take a look at that base. All right, so essentially what I have here is this is going to be the base of the gameplay area. Okay, this will be the bottom. We've got a little trim rim around it. Okay, cool. All right, so that's where we're at on that too. Now, let's see here. Let's keep going. Yeah, Chris, I can't believe you made it before 9 as well. Cool. I'm so glad you made it, man. Let's see here. Good evening. And you guys just keep typing your questions because what I'm going to do is I'm going to design a little bit, answer some questions. Design a little bit, answer some questions. And hopefully I'm answering those questions for you guys to help you out. All right, so now these two vectors basically are going to represent the meat in the middle is going to represent my wall. Okay, there's going to be a wall there. And my gameplay area, this inside area here, I've still got to put my dividers in there. They're not done yet. But this is going to get pocketed out. And I think I'm going to use 1/4 inch material for the X's and the O's, right? I'm going to use 1/4 inch material. You know, of course, we know that plywood, its nominal dimension is 1/4 inch, but its actual measurement is 7/32, right? Okay, so before you guys jump all over me, let me make sure I got that correct. All right, hold on a second. Plywood. Dimensions. Yeah, 7/32. I was good. All right. I thought I knew my stuff. And just as a reference for you guys and girls, if you ever wanted to know what the plywood dimensions are, just type in plywood dimensions in Google. And there's a cool little sheet that says actual thickness of plywood. It's a little photo. It'll show you your nominal dimensions versus your actual, which is pretty cool to know. So for 1/4 inch is 7/32, right? So awesome. So this is going to get milled out to 1/4 of an inch deep. Okay. And that will give me, when my parts, my gameplay pieces are in there, they'll be just below the surface kind of deal. All right, cool. All right. So now let's get some X's and O's here. I'm going to use a circle tool here. And I really need to know how many, how big my parts need to be. So let's start off first with a 1 inch diameter. Let's see how big that circle is. All right. And let's see, just for kicks and giggles, if I array copy that and I do 3 and 3, 3 rows of 3, 3 columns, and I do a gap in between each one about the thickness of what my wall is going to be. I'd love to have, I don't know how much material I have, but I'd love to have a 1/4 inch thick wall, right? And on the Y, a 1/4 inch thick. And if I copy that, oh yeah. So, you know, let's center these up inside of, I'm going to group them together. The letter G on the keyboard for group, to group those together. I'm going to select this rectangle last. And in my alignment tool, I'm going to align to another selection, which is that last rectangle. I'm going to center that up. And yeah, that's pretty darn good right there, because I'll have my wood and everything. I probably could make them a little bit bigger, but this will help me show me where my pieces are going to go. Okay, cool. Yep. And let's go here. So to throw up some things, if you use birch plywood, they are closer to nominal 1/4 inch, like 0.23, with that nice Baltic birch plywood, that furniture grade Baltic birch. And then of course, Calusa Cabinet says, hey, not all plywood is created equal. Some are thicker and thinner than others. And that's referring to, like, you know, if you have a higher grade of plywood, if I'm buying my plywood from Lowe's and Home Depot, I'm probably not going to get those layers, you know, that I would get in a nice furniture grade Baltic birch plywood, or even an airplane grade plywood like they make model planes out of and things like that, which would probably, and I haven't measured it, Chris, so they probably are more closer to a 1/4 inch. I'm going to be picking up my pieces. I'm going to be cheapskate, and I'm going to cut my game pieces out of simple birch plywood from Lowe's. So we'll trust the 736, but of course we would measure our plywood, right? We would put some calipers on it, and we would measure it just so we know, because we got to cut the parts out. So thanks guys for throwing that in for everybody to for helping everybody out and everything. Now, let's take a quick second here, and I wanted to do this at the beginning. I should do it at the end versus right in the middle, but I'm going to throw it out there. If there's any digital wood carver customers or anybody out there that's using Planet CNC TNG software for your motion controller software, I'm going to be putting out a video this week to show how to set up a wireless game controller as a pendant. And if any of that interests you and all, there'll be not a live video, but there'll be a video I'll be throwing out this weekend based on that. And then I also have another video for digital wood carver customers on how to install a water-cooled spindle, how to wire it up and all that stuff. So that's going to be coming out this weekend for y'all digital wood carver owners as well. So I just wanted to throw that out there while we're moving along. All right, let's answer another question before we move on to creating our little grid here and stuff. Let's go to Jeff again. And Jeff Laney, could you explain how the software works when you use your machine bed to set the Z height versus the material surface? Absolutely, I sure can. Let's go back to, let's turn off our layer 1. And let's throw these guys. All these guys are supposed to be on layer 1. I'm going to right click and move to layer 1. And the reason why they got put on layer 2 is because layer 2 was active. Even though it was turned off, it was active, or it was turned on, but it was active when I was drawing it. And when I'm drawing this design, I need to make sure that my layer 1 is on and active, bold right here. But right now we're going to turn it off and make layer 2 active. All right, guys. Let me explain this the way that I explain it to my customers when I'm trying to teach them about setting their Z height, material surface as their Z0 position or their machine bed. Now, for me, I'm sure there's hundreds of reasons of why one would choose the other. But the two main reasons that I specify is let's draw out our table. Let's say that this is our tabletop, right? Cool. Let's say on our tabletop we have a wasteboard, right? Sacrificial wasteboard. And then let's go ahead and throw a project board on here. Let's draw a router bit and a router. Let's go ahead and select all of these and let's line those up center to center so they look like more like a router. And let's group those together so I can manipulate them together one at a time, right? All right, so if I am zeroing out on the material surface, my bit, I'm zeroing out on the material surface, that becomes 0, okay? And when I'm doing something like a profile cut, pocket cut, any toolpath really, right? You know, let's talk about a profile cut right now. And let's say I do that profile cut and I'm cutting through my material, 3/4 of an inch, 0.75, right? Well, the software is cutting from 0 down to 0.75, okay? Right? Right, okay. Now, what happens if my material is just a little bit thicker than 3/4 or a little bit thinner than 3/4? And I don't know that. I didn't put calipers on it. I just threw it up on the table because I just bought a 1x4 from Lowe's and I assume it's 3/4 of an inch. An assumption is the mother of all, you know the rest. But let's say that my board was a little thicker than 3/4. Let's say it was 0.8, right? Just a little bit thicker. Instead of 0.75, it's 0.8. Well, I just told my software to cut to 0.75. So it's going to cut from 0 down to 0.75. And I'm going to end up with a little onion skin where it doesn't cut through. And I'm going to be like, damn, it didn't cut all the way through. So now I got to go in here and I'm going to try to go, okay, let's go 0.77 and do it again. Or let's go 0.80 and do it again. Well, now I'm guessing. Right? I'm guessing how that is. And so now what I'm going to end up doing is I'm going to end up overcutting, and I'm going to end up spoiling my spoil board. I'm going to be cutting into my spoil board, putting all kinds of nice grooves and everything in it and all. And it same goes if my board was thinner than 3/4 of an inch. If I tell it to cut 3/4, I'm cutting through my board and into my waste board. Right? And so I'm spoiling my spoil board. When I'm cutting into it, I'm spoiling my spoil board. So if we decide to set the machine bed, which would be whatever your project board is sitting on, in my case, it's a waste board. If I decide to use the machine bed as the Z0, well, nothing changes for me in the software. I'm still telling the profile cut to cut from 0 to 0.75. That doesn't change. But in the software, it does all the stuff in reverse. It says, okay, hey, this dude has the material or, you know, the machine bed set at 0. So he's telling me to cut 3/4. Well, I'm going to go up here and cut from 3/4 down to 0. Okay. So it does it in reverse. It's going to cut from 3/4 to 0. Now this guarantees 2 things for me. Number 1 is if I am working off the machine bed at 0, number 1 thing that's going to guarantee is I'll always cut mine through my material, because it's going to cut from 3/4 down to 0. And whether my board is a little thicker or a little thinner, it's still going to cut all the way through because it's cutting down to my waste board, right? So that's number 1. It's going to guarantee for that. Number 2, it's going to guarantee that I don't spoil my spoil board. Now I'll get tool marks, right? I'll get that bit's going to be kissing across that surface. I'll get tool marks and stuff, but I'm not gouging into it. So because it'll always cut down to 0 and never below 0. Okay. All right. So guarantees 2 things for me. I'm cutting down to 0, right? Now, the other reason, so that's reason number 1 for me to work off the machine bed versus the top of the material. If I'm doing a VCarve where I'm not cutting anything out, I'll reference off the top of the material, no big deal. If I'm using my digital wood carver zeroing block, which rests on top of the wood, and when it touches off and automatically sets X, Y, and Z, it's referencing off the top of the material. But if I'm cutting through my material, then I zero out on my machine bed because I don't want to spoil my spoil board, and I want to guarantee that I cut all the way through my material without leaving a little onion skin. All right, so that's number 1 reason for me. Number 2 reason why you would set the machine bed as your 0 position versus the top is if you were doing a 3D model cut where the entire surface of your material gets milled away during that rough cut, or even during the finish cut, where that entire surface is getting milled away. Well, now I have no more surface to touch off on for my ball nose bit, my finish cutting bit, and things like that, because it's all been milled away. Unless I make my board a little bit bigger, where my clamps are going to go, and I can touch off on that, right? That kind of thing, you know. But if I've got my board double side taped to my waste board because I'm going to mill this whole surface because there's going to be a cool ass eagle on it or something or whatever, that whole surface is getting milled away. Now I have nothing to touch off on for my second toolpath, my third toolpath, whatever, right? So I would reference my Z0 position off the machine bed. So I have a known, and I got to snap to my machine bed. I have a known flat surface to work off of. So for me, that's the number 2 reason why I would work off the machine bed versus the top. If there's a way that that top surface is getting completely milled away, leaving you with nothing to reference your other bits off of, then you work off the machine bed as your Z0. And again, it cuts from, if I'm doing a pocket cut from, you know, that's a profile there, but let's pretend that says pocket. I'm doing a pocket cut from 0 to 3/8, right? Then it's cutting from the thickness of my material 3/4 down to 3/8. Okay. You know, it's cutting 3/8 of an inch deep, right? So it does all the math and everything backwards for you. You don't have to think that hard about it. Okay. So hopefully, Jeff, that was a long explanation. Hopefully that helped clarify some things. But the 2 main reasons that I use the machine bed versus the material surface is number 1, if I'm cutting through my material because I want to guarantee I cut all the way through without spoiling my wasteboard, because my wasteboard is a jig. And number 2, if my 3D model cut that I'm doing is going to be milling that entire surface away. Or forget it doesn't have to be a 3D model. Any one of my cuts, if I'm doing a pocket cut or whatever, and my whole surface is getting milled away, then I have nothing to reference off of for the VCarve cut, for this, for that. So I want a known flat surface, so I use the machine bed. All right, which would be your wasteboard in this case. All right. So hopefully that answered that question for you, Chris. Or not Chris, Jeff. That was Jeff's question. I don't know why I got Chris on the brain tonight. All right, let's go back to our design and make sure layer 1 is active that we're drawing in, and let's continue on, and then we'll answer some. Well, wait, hold on. Let's see here. Let me see. There's a conversation going on here. Let me make sure none of these are questions. All right, they're talking plywood. Let's see here. Ronnie, let's see here. Make sure I didn't miss no questions up there past Jeff's question. All right. We're talking about good habits. All right. Ronnie Probert. I found him Menards. I'm just checking. Been there, done that. Spindle TV. All right. Chris Leach has a question. When running Mach 3, should one turn off constant velocity or does it matter? Chris. Unfortunately, if anybody is running Mach 3, please answer that question. Chris, Mach 3 is a little bit before my time. I work strictly with Planet CNC TNG, and unfortunately, I do not know the Mach 3 platform at all. I know nothing about it. It's a pioneer. A lot of people are using it for their machines and everything. I'm using what's called Planet CNC TNG, stands for the next generation. It's a little bit more user-friendly and intuitive and all, in my opinion, because back in the day, digital woodcarver customers had Mach 3. They ran Mach 3 on these machines. When I came on board, Mach 3 was phased out and Planet CNC was brought in. Now, that wasn't my doing. It just happened to be right at that time. and Mach 3 was before my time. I don't know anything about it. So I do apologize, but that is one question that I just can't answer. All right. But if anybody knows the answer to Chris's question, when running Mach 3, should one turn off constant velocity or does it matter? Please put it in the chats to help answer his question if you know it. Okay. Cool. All right. And Chris says, just ordered a corded controller for the joystick thing. Yeah. I'm looking forward to this. I have one. This is the one that runs my machine, and it's fun. You know, I have my X and Y linear movements side to side here. My diagonal movements are the other joystick. My Z up and down and my, oops, I'm on the wrong bit. My Z up and down and my jog speeds are the left, right, up and down buttons here. And then I can start, stop, pause, emergency stop a program. On the front buttons here, I can zero out my X, Y, Z axis, and I can bring my machine back to home. So all the buttons have their own functions to run the machine, and I'm going to be showing people how to do that this weekend in a video, how to set that up. But yeah, it's pretty cool. I just like it. It's fun. It's something different, right? So yeah, the joystick thing, that's what I like, the joystick thing. It's sensitive, though, man. Those joysticks are sensitive. All right, let's answer Chris's question. Chris. All right, let me see. Let me get my wallet out of my pocket here so I can sit comfortably and gear up. Let me see here, because let's see here. When performing a finished toolpath, is there a way to force Vectric to start on top and work down to a final depth versus the Vectric wants to, which is usually the depth they're in? So yeah, a lot of people may not know that on a 3D finishing toolpath, a 3D finish toolpath goes to the full depth, and it rides that full depth and only raises up or down based on the model, the contours of the model. The rough cut toolpath does passes, you know, multiple passes, you know, to rough cut, but the finish cut goes straight down because there's only, you know, it's assuming there's only a little bit of material left, a few thousandths of an inch. So it's riding at the full depth, and it's only raising up and down, you know, based on the model and the contours and all. And Chris, as far as, is there a way to force Vectric to start at the top to work its way down on a finished toolpath? In my 6 years, I've never found no. I'm going to definitively say no. I'm sure there's some workarounds that I might not be aware of, but as far as programming, or is there something I can set or this or that? No. It's designed to ride at the end. So I do not know of any way of changing that or anything. So that would be my answer for that. All right. Sorry, I wanted to have a good answer for that, but that's the only answer there is for that question. Again, there's a lot of people out here that have been running Vectric or whatever. If you know of a way, which I've never found, and you know, I'm pretty in depth in this stuff. If you know a way, I'm always up for learning too, right? Share it. But we're talking 3D finish pass that's designed to ride at the bottom of the cut, and it only moves up and down based on the model itself. The question is there a way to force it to start at the top and work its way down? And unfortunately, no. Okay. And all that. And and Rodney says, wow, you sank 3 inches when you removed that wallet. That's because that wallet, I think, is pretty close to 3 inches, right? You know, so I always sit cockeyed. A lot of stuff in there. I keep it trim and clean, but there's a lot of stuff in there. Not money, it's empty. There ain't a lick of dime in there. There's plastic. That's not real money, but though, you know, that's borrowed money, I think it's called. It's not mine. It's the bank's money or whatever. But there's yeah, it's fat. It's heavy. All right, let's see here. All right. Darwin pops back in and says, hey, wait, when you're using the machine bed, where do you touch off the X and Y? Right? All right. So when we always set the X and Y first, right? So let's say I'm working in the center of my board, right? and I'll use, let's make me smaller, this bigger. Let's say that I am using the center of my material for my datum position. Okay. I'm going to zero out, I'm going to raise up, and I'm going to zero out X and Y first. All right. Get my bit over that, that center point. And I'm going to come into my software and my controller software and zero X and Y. And then I'm going to move my router over to my wasteboard, come down and touch off my Z. Now, some people have touch plates. Some people have touch buttons that they come down and touch off on that's automatically kind of set up and all that. I'm talking about when you're manually setting your Z, you know, on that wasteboard with your touch plate or your touch sensor or what have you. Zero out the X and Y first, and then come over and touch off the Z. Okay. Now, for users that are using the digital wood carver quickset block, which sits on the top of the wood here, right? Excuse me. It is designed to touch off X, touch off Y, then raise up and touch off the Z automatically, and it sets the Z. After that touch off is done and everything, you bring your touch block, set it up on top of the wasteboard, you know, our machine bed, right, our wasteboard. Move the router over and bring it down, touch off on it, and type in 0.5 to reset your Z, so 0.5. Hit enter to lock it in, and that'll reset the wasteboard as your Z0. So for those of you that don't have a digital wood carver quickset, that would make no sense to you what I just said, but for those of you that do, hopefully that made sense. But you would zero out your X and Y first, Darwin, then move over off your board to your wasteboard, come down and set your Z. Okay, cool. All right, let me go back to here and click OK. All right, so where we left off in our design is we were, and you guys keep asking questions. It's all good stuff, man. Where we were left off is to create our dividers in here and everything. And so what I'm going to do is I'm going to take, and I need a 1/4 inch, 0.25. And I'm going to ungroup these, ungroup. I'm going to select just these 2 rows right now, and I'm going to group them together so the software treats it like one object. And I'm going to select this rectangle first and then this group last because I want to center up and down to this group. I'm going to use my alignment tool and align to center. Okay, so that way it'll center it there. Right? Cool. All right, I'm going to select this group again. I'm going to ungroup it. I'm going to ungroup it. You can, the letter U on the keyboard is your ungroup. That's the keyboard shortcut, but, you know, that's fine. I'm going to group this letter G to group this group together. I'm going to select on this, and I'm going to come in and I'm going to hold down my control and my alternate key to move this down. The alternate key keeps my part centered. No matter where I move my mouse, whether I'm moving horizontally, I can move horizontally on that alignment right there, or I can move vertically on this alignment, but I can't move, you know, you see where my mouse is down in that corner where that arrow is. I can't move down there. That alternate key is keeping it restricted to those 2 axes. So I just want to move straight down with that control and alternate. That makes it copy. And it looks like I snapped right to where I need to be, but I don't think I did. So I'm going to select my group last, and I'm going to align up and down. You know, it was so close, it didn't move. There we go, right? Now I'm going to go ahead and I'm going to use my keyboard shortcuts, guys. I want to make a copy. So up here, copy and paste. No, that's undo and redo. Sorry, copy and paste, right? Control C and Control V. So I'm going to go Control C, Control V to make a copy. I want to go ahead and rotate that copy 90 degrees. So I'm going to hit the number 9 key once for 45, twice for 90, right? Every time I hit that number 9 key, it's going to rotate that part counterclockwise in 45-degree increments. If I hit the number 0 key on my keyboard, that's going to rotate that part clockwise in 45-degree increments. Okay. All right, cool. I want to go ahead and I'm going to select this part here, and I'm going to hold down my shift key and select that. And I want to go ahead and use my alignment tool and align up and down to that selection, right, to get it in place. Very cool there. I'm going to select my group. I'm going to select my group. I'm going to ungroup the letter U. I'm going to select this group right here. Hit the G for group. I'm going to select my rectangle, hold down my shift key, select that, and I'm going to align left and right to center. You guys see what's happening here? See what's going on? Very cool. All right. Control C, Control V, copy paste. I'm going to hold down my alternate key and drag that across. Snap it right there. It's not in the right place, but that's okay. I'm going to take my group here, letter U to ungroup, come over here and select this group here. Oops, not that part. G to group and select that rectangle, select that group last, and align left to right. So it gets it centered up in there. All right, cool. So now I've got a grid. Now these parts here, I'm going to ungroup, and I'm going to start trimming and welding these parts together to create my grid. And then, of course, my O's and everything are going to be in these center points, right? These center points. Now, someone says, hey, Laney, could I just have drawn a square the size that I want and then done a offset array of 3 and 3, you know, to create those squares and all? Absolutely, you could have, right? But I wanted to do it this way just so you could see. Okay. All right. So now that we're there, we'll start trimming here in a second, but let's answer another question. Laney, when zeroing out the Z-axis on the touch plate, is there an icon that will automatically lower and raise the router? Yes, there is. So let's minimize Vectric for just a moment, and let's go into, you guys are going to see a bunch of icons pop up here. View desktop icons. Holy moly. Give it a second. There's a million of them. They're going to pop up. All right, let's grab DWC 2440 mil mode and open that up. And then while that's opening, click yes. While that's opening, let's get rid of those desktop icons. While that's opening, I'm going to take a sip of soda. Now, you guys, hopefully you realize to create this little game, it literally would probably only take 15, 20 minutes, but we're already 53 minutes into it because I'm stopping to answer questions every once in a while. And all right, this is an older version of Planet CNC, but it'll work for the time being. All right, Ronnie, right over here in your Planet CNC TNG software, this ruler with the line with that little arrow pointing down, that's your Auto Z touch off. Okay, it will bring the Z down, register it on that touch plate, and then it'll come back up where it started from and stop, and it will set the Z. All right. Now, when you are using the automatic touch off, Ronnie, that creates a work offset. Okay. Normally, when we're manually setting the machine of the digital wood carver and stuff, you're working in the machine tab and you're zeroing out your X, Y, and Z. But when you use the automatic touch off, it creates a work offset. So you will then switch over to the work tab, and that will be the tab you're working in once you've touched off that Z. That's what your numbers are going to be correctly registering as, especially that Z number. If you accidentally stay in the machine tab and you're looking at your Z, it's going to be way off, and you're going to be like, what? What is all that about? But you're going to be making a work offset when you do that work position tool touch off. Okay. Don't press the one with the little router bit, which measures the tool length. You do not have that kind of sensor. You do not have an automatic tool changer. Don't touch that, or it'll bury the bit through your touch plate, and it'll be a bad day for you on the digital wood carver. So that's the button right there for the automatic touch off. Now, if you have the DWC quick set zeroing block, These are your touch tools here, up here. Okay, and they're integrated into the TNG. All right, let's close out of that and go back to our Vectric. So hopefully, Ronnie, that answered your question. Mike has an audio video sync issue. Is ever anybody else experiencing that, or are we on track? Let me know, or let Mike know. All right, back in our design, let's go ahead and do some trimming. Basically, this perimeter right here, I need these walls and all to be blended together. So I'll start first by selecting all of these parts that I made here. And welding, let's go back into our drawing tools. Let's close that alignment and let's weld that together. All right, to get rid of those lines. All right, and let's go ahead and we'll use our trim tool and my trim tool. Bear with me a second. I'm going to offset this inward just slightly. And let me get rid of that one. All right, let me use my trim tool and let's trim. I'm just trimming around the perimeter. Guys and girls, let Mike know if there is an audio sync issue or anything, so he can kind of troubleshoot it if it's just on his end. All right. So very cool. Now what we've ended up with is our 6 squares, right? We've got our area, the areas that are going to get pocketed out and everything. And now I can go ahead and very quickly, one at a time, I'm going to select my circle, then that, and just center it, circle this rectangle, center it to that selection. This one here, circle, center. And I noticed that my little tight space right there. So I'll change those sizes in just a minute. But circle, rectangle, center, circle, rectangle, center, circle, rectangle, second. And I keep saying rectangle, it's a square. Somebody with OCD be like, dude, it's a square. Call it a square. It's not a rectangle. That one is. But let's go there. And I'm selecting this first. The object I want to align. The object I want to align to last. And I'm aligning to that last option. I'm centering it, right? Just to get my placement and stuff. Okay. Cool beans. Now, I've got a little bit of a size issue here on these guys. So what I'm going to do is my inner walls right here, my inner walls, they're going to be a little thinner than the rest. Not too bad. It won't be too shabby. It won't look too bad. I've got those 3 selected, and I'm going to hold my shift key, and I'm just going to pull them out. So it pulls out both sides, right? In and out. And I'm just going to pull that out to right about there. All right. Cool. All right. And then on this centerpiece, my centerpiece right here, the crown jewel of everything. This box is a little small, so let's go ahead and keep things consistent. Let's grab this, this, and this. Double click on it, and I'm going to hold my shift key, and I'm just going to pull that out slightly. All right. Wonderful. Okay. Can't even hardly tell the difference, can you? Now, if I wanted to look at my size, like let's say somebody's like, oh, that's going to drive me nuts if they're not the right size. These boxes are 1.245 inches, right? I could come in here and say 1.245. I could unlink this and make this 1.245 and hit enter. And, you know, I could make sure everything is all the right size. So my middle one here is going to be off. Let's link that back together. Well, no, it's not. Link it back together. 1.245. 1.245. If somebody, the reason why I'm doing this is somebody's going to say, man, straighten that shit up, Lane. That's terrible. All right. We'll get everything the same size and consistent. 1.245. Calculate. And so now all my squares are the same size except for this one. Cool beans. This one's not. All right. There's my gameplay pieces. Okay. Let's see here. Welcome back, Mike. Cecil, let's answer Cecil's questions before we move on to some more tool pathing and stuff. Laney, when Laney was visible, you can see the difference between his lips moving and the words, kind of like old Japanese conversation in English. Okay. There is I can tell you what, for I'll be like Wilson on Tool Time, right? Hiding behind that fence. We'll hide behind that comment. Well, Tim, today's advice. All right. Yes, there is a delay there. Well, I know is on my end, I noticed because there's a 10-second delay. What I'm saying in my office right now, you guys aren't hearing for a good 5 to 10 seconds. And you can see that delay in my lips from my sound. So weird, isn't it? All right, let's see here. Okay. Harvey says, making a spindle with a taper bit. Is there a way to do a rough cut? Is there a way to do a rough cut, the length of the spindle of a line following the profile, cutting multiple passes to reach the finished depth, then do a finish cut? Yeah, that would be, Harvey, that would be essentially a pocket cut, if you will. Let me see here. Let's minimize this for a second, and let's right click. All right, let's, I'm just going to do a 15-inch by 2-inch diameter. Let's get Harvey's question out of the way here for a second. Bear with me, Harvey, while I draw out a taper. Let's see here. All right, N for node editing. Let's take this and pull this down about halfway, kind of create that taper. Let's go into here and right click and delete that span to create that profile. Let's take our drawing tools and draw a line from here to here. And let's do a molding toolpath. Oops. Close the polyline tool. Let's select our line here. Let's do a molding toolpath. Select this profile. And let's calculate that. Now, the reason why I'm doing this this way, Harvey, is because I'm in VCarve Pro, not Aspire, to create that that toolpath, and everything. And so I could just kind of, show this taper for a minute. Okay, so imagine if we were making a tapered cylinder or whatever. And let's get this along the X here, this tapered cylinder. Now, if I wanted to, I could create this taper using I don't think the fluting toolpath will let me do that. Ramp overall length. I might be able to do a fluting toolpath on something like that. But if I was doing this taper here, and I wanted to do it as a pocket cut, to create a smooth pocket cut, that's a tough one, my man. That's a tough one. I could divide this project up into sections that are going to get pocketed out to a certain depth, and then move over the next section where we pocket out to a certain depth, kind of creating that stair step cut to get down pretty close to hogging away the rough material, if you will. And then, the finish cut is what's going to get you doing a finish cut. See, the swept profile allows me, it's kind of a 2-in-1. It allows me to do a rough cut. Okay, machine my flat regions and do a rough cut with a larger end mill, and then just do the finish cut with the ball nose. That's my molding toolpath. And so if we were to calculate this so you could see the difference between the two, let's turn off the finish cut for a minute. My molding toolpath rough cut is just removing this last little bit here, right? It's removing that part that's getting ramped down or tapered. So it's going to pocket out and kind of start breaking that down into those stair steps that I was talking about. And then the finish cut is going to come in and do the the finish cut is going to come in and do the finish cut on that taper. And I don't know if that answered your question and all, because the molding toolpath kind of does it all. I was thinking of a way of doing a pocket cut across the whole thing to kind of get it leveled out, then pocket cut a certain section, then another section, just exactly like this rough cut did, where only certain sections are getting milled down. I'd be pocketing out this, this, and this. But honestly, man, I don't know. The molding toolpath kind of does it all for me. It sets up those 3 pockets to get those milled down. And then my finish cut just kind of comes in and does that finish work when I'm doing a spindle in VCarve Pro. When you're modeling a spindle in Aspire and you're creating a 3D model, you have a rough cut and a finish cut. And the rough cut basically is that pocket toolpath and everything, where it's going to be hogging away the waste material, and then the finish cut's going to be cleaning up, just the same way the swept profile acts. Think of the clearing as the rough cut, and this is the finish. So I don't have a really great answer. All right, let me see what you guys are talking about here. I got to pause for the cause. Baron, what just went out? You guys seeing me? Let me see. My phone's been going off like crazy. Let me see if... You guys, can y'all hear me? Crystal, if Michael's watching, my mama said I got to apologize for saying S and giggles. Because Michael's watching. Keep forgetting Michael's watching. Michael, I hope you're watching. You got to watch my language. All right. My mama texted me and said, you got that 5-year-old watching. Stop saying S and giggles. Anyway. All right, so let me see here. You guys were good. We got audio and all that stuff. We can kind of continue on and all that wonderful jazz. Cool. All right, let's get back to my mama texted me. She's watching. That's funny. 46 years old. My mama's still getting on to me. All right, let's see here. Harvey says, in your example, skip the rough cut and just do the finish cut. The first pass is bad. After the first cut, it turns everything is good. All right, Harvey, you got. Let me wrap my head around this. In your example, skip the rough cut and just do the finish cut. The first pass is bad. After the first cut, and it turns everything is good. Why am I so dense tonight, Harvey? I'm not getting it. Let's see here. Let me go back up to question 1. Hold on, give me a second here. Harvey says, making a spindle with a taper bit. With a tapered bit, making a spindle with a tapered ball nose bit. Is there a way to do a rough cut, the length of the spindle of a line following the profile? Multiple cuts, multiple passes to reach the finish depth, and then do a finish cut. So, Harvey, are you in VCarve Pro, Desktop Pro, or Aspire for this? Because on a 3D cut, you could use your tapered ball nose bit and do a rough cut where it's taking multiple passes at multiple depths, okay, till it reaches that final depth minus, whatever little skin that you tell it to leave. And then the ball nose bit is going to come back and do the finish cut to touch everything up. I'm not seeing... That's a rough cut and a finish cut, what you're describing. You're just talking about using a tapered bit with it. I'm not seeing it. And let's see here. In your example, so he follows up and says, in your example, skip the rough cut altogether. Just do a finish cut. The first pass is bad. After the first cut, and it turns everything is good. After it turns, everything is good. Is that a question, or are you making a statement as to what happened on that one? I don't want to get hung up on it, but I'm hung up on it, Harvey. I apologize. Now, okay, Calusa says, maybe is he asking about an offset? Because, in our, let's go to our 3D cut and everything. We do have that machining allowance that brings that rough cut down to a certain amount, and then the finish cut cleans up that last little bit. That could be that. Now, oh, man, why I don't? It's not registering. I don't. Maybe it needs to be. Okay, hold on. He's saying, hold on. Let me come back here. VCarve Pro. I accidentally missed the rough cut, and it turned out, but the first minute was bad. Okay, so you missed the rough cut. All right. Okay. So so the rough cut would be the answer to cleaning that up. So that the first minute's not bad, and then the finish cut would be the finish up, right? Is that what you're saying, Harvey? Hey, I missed the rough cut. That's all right. So I think he's kind of clearing that up and closing that out, so we can move on. Cool. Sorry, and Harvey, if I didn't get it all together, if you're like, dude, that just went over Laney's head, it probably did, but hopefully you see the where we're at. Okay, let's get some, let's go ahead and get rid of our circles here. Not get rid of them. We're going to use those vectors for our O's. Let's select all of our circles here. And I'm going to offset these inward before I get rid of them. I'm going to offset them inward, 0.25. Let me see what that offset looks like. Yeah. Let's go point. There we go. All right, let's go ahead and let's select all of these bad boys. Well, what am I doing? I'm an idiot. Let's just select all those and deselect that. Deselect that. All right, I'm going to group those together for right now. I'm going to use those later on in a 1/4 inch piece of material to cut the O's out. I need to make some X's real quick. Got to make some X's. And I want my X's to fit in my part. So let's see here. What would be a good size X? Let's rotate that. I'm going to hit the number 9 key one time. Cool beans. I'm going to hold down my shift key and drag that out for a minute. I'm going to center myself up on my material, or no, to this. Center. There we go. Cool beans. I'm going to select this. I'm going to Control C, copy, Control V, paste. I'm going to rotate that twice by hitting the number 9 key twice. All right, cool beans. I'm going to weld these two parts together. Select both of those and hit the weld button to weld that together to make that X. Nice. I'm going to slightly offset it. I don't want it to be like a tight press fit in there. I'm going to slightly offset this X inward, 10,000ths of an inch, delete the original and create the new. Okay, so it just kind of fits, right? And then I'd like to just put some radiuses on these corners here. So I'm going to use a fillet tool. And let's see what a 1/4 inch. That's quite big. Let's go with a 1/16 of an inch. Let's see what that fillet looks like. Oh, yeah. Looking good. Just going to go around on all 4 of these corners here. And there we go. Let's do a little bit of radius in there and there. There and there. That was already radius. That's good. All right. So we got our X. And now if I take this X here, Control C, Control V, and select this rectangle, I'm just going to aligned to the center, right? And, you know, I could do it that way, right? I could do it that way if I wanted to, but my gap, you know, I could also array this, you know, 3 rows, 3 columns to array that out. And, you know, if I basically wanted to look at my height here, or my width, should I say? Let's look at my size tool for a minute. My width is 1.6 or 1.1639, right? From the left side to the right side here. You with me? You're with me. All right, cool. And if I wanted to offset this, I would need to know like how much to offset, right? You know, if I'm gonna use my array tool, we don't talk about the array that much. So I'm kind of, you know, I need to do an offset. An offset will measure from the left side to the left side of the next part, right? So I need to offset this a certain distance. Well, my distance here is, you know, for the piece itself, it's 1.1639. We'll put it over here as well, 1.1639. But there's a distance that it needs to travel to fall center of this, right? And so I'm going to cheat for a minute on this one here, and I'm going to measure. I'm going to measure horizontally from this point to this point, and it's 0.208, right? 0.208. And, you know, that's kind of my number there. And so in my array tool, if I came in here and I added plus 0.208 equals plus 0.208 equals, right? This would be a negative number because I'm going down, not up. I'm going down. So the Y would be a negative number. I should be able to copy that and fill all these holes, right? And of course, this one's a duplicate. Let's delete that. But I should be able to copy that and fill all those in. You guys agree? Of course you agree. You just saw it happen. All right, let's go big screen. All right, so basically an offset is measuring from the left of the part to the left of the next part, right? That's an offset. So all I did was measure how wide my part was. I drew another part here, kind of got it centered in the square, and then I measured that distance, you know, from here to here. And I added that to that offset to get so it all falls in center, right? Cool. All right, let's go ahead and let's select all these parts, except for those. And again, I'm going to group those together. And let's move those over there. That'll be my X's. X's and O's. X's and O's. All that wonderful jazz. All right. Okay. Let's create some toolpaths. All right. Now, if I take these two parts right here and group them together just for a minute, not delete. That was the delete key. The G key is group. I'm going to group this together for a minute. Group. Now, this part, if you remember here, where'd it go? Let's preview that visible part. If you remember here, I had that lip right there, right? Well, the lid's going to fit over that and press down to that lip so I have my full part. And this height here, if you remember, is 1/4 of an inch. So I want to pocket, let's ungroup this. I want to pocket from here, okay? I want to pocket this area 1/4 of an inch down, the lid, okay? All right, you guys with me? I don't need this internal rectangle here, just this. I want to pocket this lid. And now when this gets cut, this gets pocketed, this is going to get radiused here, right? This is going to get radiused here. I need to go back and radius these and recreate that that first pocket cut after I radius this. So I'll go back and do that. You know, I know that, and I just didn't do it. But let's pocket this out. And we're going to go more than 1/4 of an inch. We're going to go slightly bigger, not very much. We're going to go about 0.27. Because I want this lid to be able to fit and close tightly on this here. Now, this pocket cut that's going to happen, it's going to be a tight fit if I don't create any kind of allowance, you know, for this part to fit into. If I don't create any kind of allowance, it's going to be a very tight fit. So I want to do a allowance. I want this pocket to be overcut so slightly, not much. And it's going to be a negative number. And I'm going to go just 0.002. So it's a nice fit, friction fit. If that's too tight for you still, you know, and you're like, man, I can't even pry these two parts, you know, go bigger. But I like to sneak up on it. So this is going to be my lid pocket. Cool. 0.25 end mil. And let's calculate that out. Reset that preview that selected toolpath. Let's do our profile cut. Let's cut that part out. I'm actually going to tie it in with this profile cut, right? We don't need to have toolpaths for every single one. So I'm going to go back into this base, and I'm going to do a profile cut, and I'm going to call it the base and lid. Base and lid. Profile cut, calculate. Okay, well, first of all, it would help Laney if you actually selected the lid profile and calculate. All right, so we have that lid that's going to fit over. And of course, let's do this base outer pocket here. Oops. Right. So that lid fits over that, right? So far, you guys get it? The top and the bottom? Cool. All right. Now, on my pocket cut here, I need to radius these inside corners so that my lid's inside radius is, if we go back and look, my lid's inside radius is, you know, can't fit a square corner in a circle, right? Or, you know, what is it? Can't fit a round peg in a square hole kind of thing, or a square peg in a round hole. You could, but it'd be trouble. So I need to create a little bit of a radius here. I'm going to use my fillet tool, ladies and gentlemen. Then we're going to answer some more questions. I'm going to use my fillet tool, and I'm using a 1/4 inch bit to cut this stuff. So my radius is 1/8 of an inch. And we're going to come in here and fillet these 4 corners. Wonderful. And we're going to go back into this pocket toolpath and redo it right there and there and click calculate. Okay, cool. So now, you know, when we do that pocket, it'll round those corners off so my lid can fit around it, right? Right, right. Exactly. Let's see what we got here. Any more questions? You guys go on in and ask the questions and stuff. All right, so let's get our gameplay area here. Now, of course, you know, on all of these, when that router bit is pocketing these areas out, they're going to be rounded, right? So you could just, leave it be and let the router bit do it, where it's going to radius off anyway, where it's turning that corner. I kind of like to, if I know that's going to happen, then I kind of like to just go ahead and get it done, right? So I can come in here and, just click on that with that fillet tool and get all those parts already rounded off. Right. And all I'm doing is just getting on the corner, that check mark pops up, putting in that 1/8 of an inch radius, all that good stuff, right? Right. Okay. So now I want to go ahead and pocket these guys. And I'm going to pocket this down 1/4 of an inch. So I could actually tie it in with this. So it's going to be 1/4 of an inch. And I can tie it in with that. And we're going to rename this. This is going to be base pockets. And calculate. Cool beans. Fun stuff. All right. So now we got a cool little pocket tic-tac-toe game that has a lid. It closes up. On the other side of the lid, if I wanted this to be a 2-sided project and I wanted to customize this, I could, lightly, because I only have an 1/8 of an inch material. If I had a laser, I could laser engrave a design on the lid. I could, lightly etch something, a V-bit with a flat depth of just a few thousandths of an inch, right? I could engrave something, someone's name or whatever, right? I could do it as a 2-sided job where there's some kind of little bit of a decorative design there. But when these two parts go together, all the, X's and O's will fit in here and everything. Now you're going to say, wait a minute, Laney. No. The X's and O's aren't going to fit in there because look at all those X's and O's you've got. All those aren't going to fit. Well, we're not going to have, there's only so many X's and so many O's that you're going to use. You won't use all 9 of those. But if I do cut these out of 1/4 inch thick material, right? Get what I'm thinking? If I cut these out of 1/4 inch material and I go to stack them in here to put the lid on, guess what's not going to happen? Lid's not going to close, right? Lid's not going to close because it's coming all the way down. It's coming all the way down to that. I left 1/4 of an inch here. And, this is only a 0.27 inches deep over here. And so I only left myself just a little bit of air room. Air, A-I-R, air room, a little air space. There we go. When that lid closes tight on here. So what's my alternative? My alternative is that my outer perimeter here, I could shallow it up some to where it's just a little lip that this hooks on, which of course raises this pocket up. But then again, I'm not, I'm only cutting 1/4 of an inch. So if I go 1/8, I'm only adding 1/8 of an inch to this, and it still doesn't fit those two parts in there. So my dilemma is, if I want this to be a little pocket pal game and everything, my X's and O's, 1/4 inch material is not going to cut it. I need to be 1/8 inch material. 1/8 inch material, right? So for my little game pieces, if I want to do this, or I make this whole thing out of thicker material and, make my pockets deeper, right? And stuff like that. But I want this to be a small, very thin, almost basically thinner than my wallet. I want this to be thin that, it's just a little pocket carry around little game, right? So I'll go ahead and cut the X's and O's out of 1/8 inch material. So let's go ahead and I'm going to right click and I'm going to open up another VCarve Pro. And then we're going to answer Ronnie's question. Ronnie's got a good question. Hold on a minute. Let's create a new file. Let's go with a single-sided board. It doesn't need to be that big. Let's go 8 inches. And by 6.5, let's go 6 inches. By 1/4, by 1/8 of an inch thick plywood, which is not the correct dimension, but we're going to leave it there because we're going to use some good stuff, right? Good stuff. I'm going to work from the bottom left corner, material surface. Let's calculate that. Or not calculate, but click OK. Over here, I'm going to copy these vectors, and over here, I'm going to paste them. And then I'm going to take all of these guys right here, and all of my O's are grouped together. I want to ungroup them, and I want to group them together individually. So G, select these two. G, individually, group those together. I don't want them all grouped as a group. I want them individually grouped. And then my X's, I just want to ungroup. And I want to select all these and I want to nest them. I'm going to nest them. I'm going to be using an 1/8 inch end mill to cut them out. Right? Let's put a 1/4 of an inch in between each one. We can keep them away from the border. That's fine. We'll let them rotate a little bit. And let's preview. All right, my rotation didn't allow these two parts to fit in there, so it was trying to cut them out of another sheet. Well, that's no need to do that. Let's just change the rotation. I'm going to go Control Z. Undo that. Let's change that rotation a bit. Let's go 45 degrees. And all right, let's reset that. Let's do that. Let's get rid of this border gap. I can go right up to the border on it. That's fine with me. 0 border gap. All right. What's my board size? I'm going to go 6.5. Right? All right, let's nest. Oops, that one is not grouped. That needs to be grouped. All right, let's nest those. There we go. There we go. All right, let's create a profile cut. A profile cut. We can close our nesting tool. I'm done with that. And we're going to create a profile cut. Going to cut 1/8 of an inch deep. I'm going to use an 1/8 inch end mill. And outside of the line, the software is smart enough to know that I have holes in the middle of my circle, so it'll cut on the inside of the line for those holes. I'm going to use a little piece of double-sided tape to hold this down. I don't want any tabs on these because I do not want to be sanding and playing with them for tabs. And I'm going to do my tic-tac-toe. X's and O's. All right. And 0.125 ml. Let's go ahead and calculate that. Preview that visible toolpath. All right, there's our parts for our little tic-tac-toe game. Get rid of these little dots here. And we've just designed a little fun, very simple. You guys saw me do it, but I'll leave the file in the description of the video that you can carve out of a 1x8 12-inch long piece of material, 3/8 of an inch thick, to cut the game board out in the lid. And then a little piece of 1/8 inch material. You guys can cut out the X's and O's. And yeah, we got ourselves a cool little fun kids toy. If you want to customize them, you know, flip it over and do some little customization. Just remember, you only got about 1/8 of an inch of material there, so don't cut through it and all that good stuff. Let's answer Ronnie Probert's question. When will you be designing an electric guitar? And Ronnie, I tried to push that off as long as possible. No, I'm just kidding. And will you do a woodworking shop? Can you do a woodwork shop cutting it out as well? I don't know if when I'll do a let's set something definite. So I have to put my feet to the fire and get it done. I've been putting it off for 6 years. Might as well do it now. This will be my first guitar, right? Kind of thing. So let me create the design. We'll go 2 weeks. So not this coming Tuesday, but next Tuesday, we will start designing an electric guitar. And then once we get the design done, we'll set up a in the shop class and we'll cut it out. How's that? All right. So feet to the fire. You heard it here. Thanks, Ronnie Probert. No, I'm just kidding. That's good. All right. So Ed, can you do a laser training someday? Absolutely, I could do a laser training someday. And, you know, I did a video that wasn't a live video. Was it live, guys, when I was doing the training on tile? I think that was live. The tile class. I did a laser video, what was it, last week or the week before last? So check that out on Spindle TV, how to laser engrave in ceramic tile, right? Using the new laser module tools, Vectric 10.5 laser module tools. But yeah, we can throw in another laser video down the road coming up for sure. All right, let's see what we got here. Place magnets on the back. Place magnets on the back, right? So we could place, if we have, we would need some very small magnets. So you're talking about magnets on the back for the lid to snap closed and be magnetically closed, right? We could put some magnets if I made this a little bit wider and I reduced some things down, or made my profile cut, my little profile cut a little bit bigger. I could throw a magnet in there, or I might be able to throw a magnet in here and here, and then bury 2 magnets in there. So when the lid snaps shut, it snaps on those 2 magnets. I do them diagonally. I wouldn't put 4 magnets on, just 2 would be enough. I could probably fit a small little rare earth magnet in there for sure. We could do that. And then do a, you know, a little pocket cut for the other magnets for that lid to snap shut. So that's a great choice. You're going to make the guitar out of ash? I don't know. I'd have to go buy the wood. So I'll have to go to my hardwood dealer, see what he has available. You know, ash or spalted maple, because the guitar I wanted to make was a river guitar with epoxy resin fill, you know, like a river table. But we'll do just a regular guitar for the first one out of the gate, then we'll get adventurous with epoxy and all. But I don't know what I'd make it out of, honestly, to be honest with you. I'll have to see what kind of nice wood I can get from the hardwood dealer. So we'll see. So, Mama, if you're still watching, I'm going to need some wood money. I'm just kidding. I'm just kidding. Mama says she'll play it. Let's see here. Let's see here. Still have a quick question about Aspire. Still have a quick question about Aspire software with 60-watt laser. All right. 60-watt laser or the 6-watt laser? The 6-watt laser you use your Vectric software with. The 60-watt laser, which is its own standalone machine, Baron, you could use your Vectric VCarve Desktop Pro or Aspire to create your vectors, but you would export those vectors out so as a DXF file. You would, once you had your design made, you would export them out as a DXF file, and you would import that DXF into Lightburn or RD8 Works, whichever your laser software you would be using at that time, and all that wonderful jazz. But you would not be creating a toolpath or anything like that to run on the laser. You have to export your DXF out. So if I was exporting this out, I would take it over to my RD8 Works or my Lightburn, and then I would be setting up the burn rates and power settings and all to cut those parts out on a 60-watt laser, 90-watt laser, 40-watt laser. But if it's the 6-watt digital laser, then you would use either your pocket profile or quick engraving or your new laser module tools, right? If you're cutting parts out there, but not on a 60-watt. Not on the 60-watt. Nope. All right. So, well, hopefully you answer that question. Right. So you wouldn't be doing it on a 60-watt. You'd be doing it on the 6-watt. But the 60-watt, you would be creating your design, exporting those vectors out as a DXF, and then exporting out to laser. Now, if any of you other guys and girls have a 60 or 90-watt laser and you have found a way to export a toolpath out to where the laser runs that toolpath, you know, the X, Y, and Z, you know, or whatever, let me know. But I've never heard of it to this point. But hey, anything is possible, and I don't know everything. Right. I don't know everything. So, but that's how you would do it up to this point, unless someone says, oh no, here's a post processor you can create for a laser and export it right out. I don't know of it. All I know is DXF, export it out, bring that into Lightburn or RD8 Works, create your cut and power settings, whether it's a scan or a cut path and all that, and all. Yeah, because I don't think a regular big laser has can do pulse width modulation where it can do shading and all that stuff. No, it can do shading. It can do pulse width modulation because it does pictures all the time. Yeah, so there may be a way. I just don't know about it. What laser do I recommend? I recommend the 60 or 90-watt digital laser from digitalwoodcarver.com. Digitalwoodcarver.com. Go to products, CNC and lasers. Scroll down to the bottom of the page. 60 or 90 watt. That's the one I would recommend. All right, ladies and gentlemen. Well, we've been at it for an hour and 48 minutes. I'm going to wrap up here. We just made a fun little kids toy, little game box. Got to throw some magnets in there, right? Well, if you want to. If you want to, you want to. And find some places for some small rare earth magnets. I'd have to get on Amazon, see what size I can get them in, what size I would need to make my pockets and all. But yeah, there you go. Fun little kids toy that can be portable. Take it with them on the road. Travel size. Fun stuff. All right. Most of this was just about Q&A, right? Hopefully you guys had some good questions. You did have good questions, but hopefully you got some answers, the answers you want and all that stuff. And if you have any more questions, we're going to wrap up here in about 6 minutes, 5-6 minutes, and say our goodbyes. Suicidal says, why does Vectric do nonlinear path in Raster sometimes? The only time in a raster, the only time it'd be doing a non-linear path in the raster, that back and forth, is when it's doing the final profile. And let's get your picture off there and let's go to here. Let me see here. The only time I could see it, let me just select the vector here real quick, is when I'm in a raster cut. The only time I could see it doing a non-linear cut is if I'm doing a profile pass, first or last, where it does an offset round and round, and then it comes back and does a raster. And I could do that profile pass first or last, or none at all, where it's just back and forth, back and forth, back and forth. Right? Is that what you're asking, or am I misunderstanding the question, what you mean by linear pass? Let's see here. Suicidal follows up. Like it starts at the bottom, then jumps up to and starts, then finish, and then come back to a particular. Okay. Why does it move from one place to the other? So it starts at the bottom of the design, then it moves and jumps up to the top, then it comes over here. Is that what you're talking about, where it kind of jumps around? Because I know, like, if you're talking about if it jumps around, like it does this pocket, then it'll jump over to this pocket, then that one, and it doesn't do it in a linear fashion, like this one, this one, this one, that one, that one, that one. It's based on the vector selection order. By default, it goes the shortest distance start point to start point in a XY direction. VCarve's all over the place unless you use a particular vector selection order, and only in a profile toolpath. And I know I'm not answering this question, but I might as well finish up what I'm saying here. In a profile toolpath, we can start from the shortest path by the grid, bottom to top, left to right, and vector selection order. And by default, your cut is set to shortest path grid, bottom to top, left to right, and vector selection order is not selected. That's your default selections there and everything. So in a profile cut or whatever, you can choose in what direction it is. All the other toolpaths, you don't have that kind of control. The order you don't have. You've got the vector. You do have the option of choosing vector selection order. Right? Now let's go back and answer his question, because he's adding more to it. Okay, maybe it was a glitch. You're right. It has always worked normal. Okay, hold on a second. Let's go back here. Ronnie, thank you. I'm glad you have that. And let's see here. Like it starts at the bottom, then it jumps up and start, then finish, and then come back to the part it didn't do. Yeah, it jumps around and stuff. Jumps up an inch, it'll, I know now on a 3D cut, where like on a 3D cut now, it'll carve, and all of a sudden it'll skip a part and then carve again, and then it comes back and touches up that part that it skipped, right? I honestly don't know why it does that. That's always a question I've had for myself. But if we look at a 3D finish cut, right? Let's grab really quickly a piece of clip art, and just for a minute. We're going to throw him right in the middle of everything. Let's move him to move to layer 2. Let's turn off layer 1. All right. So just as an example really quickly, let's do a 3D finish cut. Close 3D finish cut. We'll use a, let's size our horse down. Okay. Let's click OK. No, I don't want to change that. I'll fix it in a minute. Model is the boundary we'll do for right now. We'll do a raster cut with the grain, 0 angle, and we'll calculate. Let that run out the clock. Oh, wait, what bit did I have in there? That's fine. 1/8 inch tapered bone is fine. Now in this, when it's cutting, we should see, if I slow down the cut preview, we should see where it skips a part, and then it'll come back and clean up that part. What suicidal at all times is thinking or saying. If we reset this preview back to a blank board, if I slow down this preview, preview the selected toolpath, let's not slow it down that much. Let's kind of speed it up slightly. And let's here, wait, hold on. Let's stop this for a second. Let's move this and square this up so we can see here. And let's preview that toolpath again. So as it what it's doing here is it's coming up and then it's coming back, and it's going to bring this leg up, and then it's going to come back and bring this leg, and then it's going to come over and bring this leg, right? Get those two things together, and then it's going to bring these up to where they're about even, coming up here, and then it should jump over once it gets to the body. Should start working its way over a little further. Now it's skipped all this, right? You see all this down here? See, it's already up here. Now it's coming back, and it's going to bring this leg up. And it should join it in with the rest of the body. Nope, it's going to bring this one up. Slowly bringing those up. Now it should bring both of those up now that they're tied together, and tie that into the body. Once it comes into the body. Now, mind you, the horse's tail is way down here. It hasn't done the tail yet. And let's speed this up a little bit more for just a little bit. Now we're getting into the tail. So now it's kind of going to bring that up and start. It's getting everything kind of up to where it can start doing a longer linear pass, or a longer, linear pass and everything. So it's kind of bringing everything up. And then now it can start traveling a little bit more to speed up that time and everything. So now it can start traveling back and forth, but it jumps around. It starts bringing these individual parts up to where they need to be. And then it can start, kind of passing. So let's speed it up just a little bit more for time's sake. As it gets along, it's going to start getting into the neck. Here, now it's going to bring that tail up, and then it's going to bring this up to it. Notice how it's skipping this part right here. Then it's going to come back after it does that. It's going to come back and get the bigger cuts. It's kind of doing all the deeper areas. It's going to start working this. Now, again, it's left this part totally undone. Now, it may not clean that part up because that's not part of the model. We're using the model as the boundary, so it's not going to clean that part up. I'm sorry. That's going to stay right there unless I pocket it out or something. And so it's doing those linear cuts. It's kind of moving and everything, but it kind of jumps back and forth to get everything kind of where it needs to be so it can run longer, pass without so much of a short distance. And I don't know, there's a reason or a rhyme for it, Suicidal. There's a reason for it. I don't know. I think it's just because, it's trying to get all this short stuff done so it can run that long pass to kind of minimize that run time. And then it brings things up, the smaller stuff, it brings it up, and then it's continuing that pass, working its way, and then it can continue that pass. And so it has to skip around to bring those parts up. And I don't know the science behind it, but there is a reason for it. So, it's there's a reason. There's a reason for it. All right, let's go ahead and reset that preview. Let's close that out. Let's get rid of that 3D finish cut. Delete this. Let's get rid of this 3D model. And preview all those toolpaths, and we'll end with that. It's 2 o'clock, so now's the time. Is there a way to clean that up after the fact? Is there a way to clean that up after the fact? Yes. The 3D finish cut, is there a way to clean it? Yeah. When you say clean it up, you're talking about like run another cleanup pass over that whole model? Or are you talking doing a profile cut and cleaning up that pocket where that tail was and all that? Because that'd just be a profile cutout kind of thing. Let me know, Calusa, which one do you mean as far as a cleanup after the fact? Let me know what you mean by that. Okay, just by the tail. That area by the tail. Yeah, so that would be a pocket. You could, when that Control Z, I could very easily come into my modeling tab and create a boundary around my horse. And again, let me undo that. Let me get back into layer 2 here. Make sure layer 2 is active. Turn that off. And let's do that again. Create that vector boundary. And now I have this vector boundary right here that I could go back and do a pocket cut on to clean that up. Right? So ungroup that, and I could come in here and select a vector boundary, and I could do a pocket cut to clean that up, to clear that up. So there we do that. Having issues with splitting and rebaking 3D models. Getting small pinholes. All right. Not slicing, but splitting he's talking about. That's an aspire function. Let's close out of this. Let me save this because I'm going to provide this file, not the horse, but though let's get rid of the horse. Horse is a horse, of course, of course. Really quickly, we'll wrap up with that. That'll be the last question for the night. Let's save as, right? Darwin Bradley, save as, is we're saving this, giving it a new file name. I'm just going to call it tic-tac-toe for right now, and option line class. We'll do that. All right, let's exit out of tic-tac-toe for a minute. Let's exit out of this one. Let me save this one. X's and O's. I'll just do that for right now. All right, let's quickly get into Aspire really quick, and let's split a model and put it back together and show you what he's talking about pinholes. So he's saying having issues splitting and rebaking a 3D, getting small pinholes. that won't fill in with the sculpt tool. And so let's create a new file here. Let's go, I'm just going to go 12 inches by 12 right now for right now, 3/4 of an inch. I'm going to click OK. Clip art. Let's go to clip art. Grab this model right here. All right, let me size this up. All right, I'm going to take my curve tool here and I'm going to draw a curve. Right here. And I'm going to use that curve. Let me all right, I'm going to use that curve in my modeling tools here. I'm going to go to split model. So I'm going to make sure that I got my curve and my horse selected. I'm going to use my split selected component. And that's going to cut the horse's head off. Michael, close your eyes for a minute. I'm cutting the horse's head off. All right. So let's go into our 3D view. So that has cut the horse's head from part A to part B here. And on part B, I'm going to come in and let's go out here. And in part B, I'm going to rotate this part by clicking on that. And I'm going to grab this pivot point and drag it right up here to the back of the neck so that I can rotate this part down to make the horse bow its head a little bit more and stuff. Now, let's say, let's come into our 3D view. Okay. Now this part needs to blend properly with this part here. So let's go to our combine mode and make sure that they are a merge. Okay. And let's click here. Now, if I come in here, a lot of times, which I got to do some smoothing and all, what he's referring to is when he's splitting the model, he is getting small pinholes. So if I take this and let me just kind of, let me bump it out a little bit to kind of create some pinholes. Hold down my control key and micro bump that out a little bit. I'm just going to use this upper part as an example. Let's say I have let's say that this was in the middle of my design, right? Little pinholes and everything. What the problem he's experiencing is he's trying to go into the sculpting tool. First of all, I got to select both of my models. Let me close this, cancel that out. I'll take this newly positioned head and I'm going to bake it together for a minute. Bake that into one. Okay. And use my sculpting tool. And on my smooth tool here, on this seam, let me use my twiddle. Twiddle is where I want to kind of move around. Let me get this on the seam here. On my smoothing tool, I'm basically just going to come in here and start blending and smoothing this model back together. But my seam is a little off right there, so I'll remove some wood. But when I start getting into here, let me twiddle up to where our little imaginary pinhole is. Twiddle, see, zoom back in. You know, in here, in this area where that gap that I created is, if I go to start, like, smooth tool's not the right tool at all for this, because the smooth tool, all that's going to do is start spreading the gap, right? We don't want that. So I want to undo that. Okay. If I start trying to fill in material, to fill in deposit material, to start, trying to fill that gap, it's not really filling in. I have to kind of, and what I've done, if I tilt this to the side now, that gap didn't fill in. But if I turn this to the side, let's turn him around. All I've done is created a big shark fin on his neck. It's building up. That add material, that deposit is just building up that material, but it's not closing that gap, right? It didn't close the gap, those pinholes and stuff. So what you have to do, the only way around that is, first of all, let me close this and discard all these changes, discard those changes. And let me come back to undo the bake the component. And what you have to do is, before you bake, you've got to overlap. Your component has to overlap completely the next component. It's got to blend into that next component where there's no air gaps or no voids. So, you've got, either change your split seam or what have you, if you can't overlap, without totally distorting what the design should look like. But you've got to overlap so that there is no pinholes in there, because once it's baked, they're baked in there, and you cannot add material within that gap. Now, in my case here, on my overlap, I can now select both of these guys. I can bake them together. Go into my sculpting tool path. And let me twiddle my view. Twiddle means move around and things. So I just want to kind of be able to focus in on this area here. And the first thing I'm going to do is do a little bit of smudging. So I'm going to kind of pull this. Oops, that was the wrong smudge direction. Let me undo that. Undo brush is a wonderful thing. I want to do a bit of smudging. Not much. Nope. Maybe the smudging I don't want to do. Let me undo that. Let me do some smoothing. Oh, okay. Just all I need to do is just kind of smooth. Let me twiddle that view. And let's and then smooth it out. And then twiddle. Let's get this back into full view. and what have you. I can clean the rest of that up with profile cut and sanding. But you have to overlap. That's the only thing that you can do, Rodney. You've got to get more of an overlap so before you bake. Because once those pinholes are baked in, you can't fill them up. Now, if they were, depending on where the contour is or where those pinholes are, now I could create a vector around that the area where the pinholes are, and I could, if I had, I could create a shape, a flat shape that fills those holes in. But then I got to make sure I don't build it up too much to where, I could draw, like if I, for instance, let's say I had a pinhole here. That's too big to be a pinhole, but that's okay. You guys get it. Let's turn this comment off. If I build this shape up, whatever height it is, let's go into the 3D view. And of course, let's bring that down a bit. I could fill that material in. And then once I've got everything baked together, so I could take those, fill in those pinholes with my Create Shape tool. I could bake that together. And then I could sculpt again. And I could come in and just start smoothing that away. That kind of deal. Right? So that's it, guys. That answers Rodney's last question. And with that, I'm going to go ahead and say good night. We're going to close up for the evening. Hopefully you stuck around and you saw some questions and heard some questions, got some answers. Rodney Roberts, I hope that answered your question a bit, because you could draw around those overlap areas and fill that in with the Create Shape tool and then smooth them out or clean them up, but the best thing is before you bake, make sure you get a overlap on those slices, especially on the sliced areas and stuff. All right, everybody. I want to thank you for joining me. I really appreciate each and every one of you for sticking with me this long. Until next week, I'll see you soon.